So, we have been talking about some of the historical background of where psycholinguistics come from, what are the different thoughts, what does contemporary psycholinguistics really concern about, and so we have talked about that in the earlier part of this lecture. Now, let us move to a different topic. Let us move to where language really comes from. Now, this is probably something that almost everybody would have thought in at some point of time in their lives, and in this section of this particular lecture, I will try and take you towards various theories of where language really comes from. Again, I am not really because of the scope of this course is such, I am not really going into much detail of each of these different theories, but I will try and just put forth some of the very interesting proposals that have come up in when you talk about evolution of language. One of the first things, and a really funny thing that you will really come across when you are reading articles on evolution of language, is something which was said by Bickerton back in 2007. And Bickerton says that the evolution of language is such a far too vast and a complex and a vague concept for anyone to say anything sensible about it. So, he says it is such a vast topic, it is so complex that it is very difficult for somebody to say anything that makes sense. The aspect here is that different people might be talking about evolution of language in their own ways, and there is so less crosstalk between all of these different disciplines, and because the evolution of language is such a vast biological and psychological or a cognitive phenomenon, that any of these different approaches might not really be grasping the totality of this. So, it is very difficult for somebody to really comment about evolution of language in its totality, and again, this is one of the things that people who have been interested in evolution of language have realized and acknowledged at various points in time. That is pretty much what I have been saying. So, let us move to some of the developmental milestones that might have contributed to evolution of language. So, one of them is the size of the human brain increased and differentiated from that of other species, apes and chimpanzees, around 2,300,000 years ago. So, that could be one of the major milestones. Our brain evolved, the number of neurons and the kind of connections probably differentiated, the way the organization of brain was kind of differentiated these many years ago, and this one could be one of the milestones that might have led to our brain having an extra capacity to use language in such a sophisticated way that we are using. Obviously, it has been a changing process. The brain has not stopped evolving since that particular point in time. So, obviously, our abilities are getting better and better probably by the day, but the idea is this probably was one of the milestones that would have led or paved the way of evolution of language. Another very interesting thing that happens neurally is this aspect of Broca's area. Now, Broca's area is an area in the inferotemporal cortex, in the inferior frontal cortex, that is attributed the function of production of language. So, Broca's area, the neural substrate for language production, was formed around 2 million years ago. So, once the Broca's area was formed, that is the milestone that would have probably led the way of producing language around 2 million years ago. Another thing is human vocal apparatus, the vocal apparatus that is used to produce language differentiated from the ones that was being used by apes around 60,000 years ago. So, around 60,000 years ago, things like lowering of the larynx happened, we got smaller and more flexible tongues that we could use to create all of these different kind of sounds. You had this finer musculature of lips that could be very easily wielded, and all of these things put together, that is basically your vocal apparatus, came together to allow us to make certain kind of sounds. There are certain kinds of sounds that the apes make, and apes have been, people have been trying to make them talk or produce sounds that we produce, and it's typically not possible because their biology, their vocal apparatus, the structure does not really allow that. Our structure, the structure of this species, the structure of vocal apparatus in this species kind of differentiated around 60,000 years ago from the apes, and again that might have also led to the evolution of spoken language, the evolution of speech for that matter. Here is a diagram, really comparing the vocal apparatus of the ape on A in panel A and the vocal apparatus of a human being in panel B, and you can see there are very striking differences. Things like, say for example, the larynx is in much lower position. The voice box that allows these vibrations to transfer to get communicated is much lower in the human vocal apparatus than in the ape vocal apparatus. That is probably one of the things that is not allowing them to make these kind of sounds. Further, again we can talk about one of the things is further the hardest problem, however, it's not really only production, it's not really only the physical or the neural apparatus. One of the hardest problems that people working in evolution of language have come across is the growth of syntax. Where does grammar come up? How does grammar start playing a role in language? Where does this sophistication, part of the sophistication of our language can be attributed to grammar. Where is this coming from? How is this started? How did this start to evolve? So this is one of the questions that has really troubled a lot of people interested in this. And there are two major points of view, two major perspectives about this debate. One of the perspectives is the biological perspective. I will really touch upon this in a brief moment, and the other one is the social perspective. So let us look at the biological and the social perspectives. Now, the biological perspective is mainly championed by Noam Chomsky. You must have heard of him. If you not, he is one of the oldest linguists. I have talked about Noam Chomsky in the earlier lecture when I was talking about. Now, Noam Chomsky, Hauser and Fitch, they came up with this description of something called the faculty of language broad and the faculty of language narrow. So, they are saying they are differentiating this language evolution or the ability of language into two aspects. They are saying there is one conceptual intentional system, which is the faculty of language broad, and then there is one very specific system to humans that is called the faculty of language narrow, that kind of achieves this task of recursion or generativity. Let us talk about this in a bit more detail. So, they distinguish between faculty of language broad. This is basically about organism internal features, a sensory motor system, attention and perception, those kind of things, and this sensory motor system interacts with the conceptual intentional system. So, what do I have to talk about and how do I have to talk about it? Do I want to talk about my vacation? What are the concepts that are there? Probably a beach, maybe a sun, maybe a hill, maybe a sunset, maybe the fruits I ate, maybe the party I had. The conceptual system and the intent. How do I want to talk about it? So, a sensory motor system and a conceptual intentional system that mediate the language of an individual. One of the basic components of whatever our language is can be captured by these two concepts. Also, the faculty of language broad includes a biological capacity to learn and master any human language. So, any of the human. So, when a person is born, it is not really sure whether he is born into a family, is going to be born in a family which speaks Hindi, English, Russian, Punjabi, Urdu or whatever. So, the idea is at birth there should be a biological capacity, because we are talking about the biological perspective, and Chomsky and Hauser and Fish, they basically believe that there is something unique about human languages that must be inherited from the genetic makeup, from the genetic evolution which goes back millions and millions of years. So, there must be a biological capacity which will allow us to learn and master any human language, obviously with the condition of adequate input and so many other things which we will talk about at some later point. So, faculty of language broad contains two organism internal features. First is a sensory motor system, second is a conceptual intentional system, and it also includes an ability to master any language that the child is exposed to. I am talking about a child, I am not really talking about adult language acquisition at the moment. Obviously, the system will allow adults to learn other languages as well, but I am just kind of defining the focus of what the discussion here is. Another very important thing that is mostly unique to humans, again in the views of Chomsky, Hauser and Fitch, is a computational system. Now, this computational system is a narrow syntactical system, it is a outlaying of particular kinds of rules. And this outlaying of particular kind of rules generates what are called internal representations and maps them on to the sensory motor system via phonology. This is how this word, each word has to be spoken, this is the organization, this is how these phonemes have to be organized, and the conceptual intentional system via semantics. So, the sensory motor system interacts with this recursion system via phonology, and the conceptual intentional system interacts with this particular system via semantics. What do you have to talk about? What are the different ways that you can talk about it? How can you write the same sentence in so many different forms? These kind of manifestations. Again, I am not really giving you a really a real verbatim explanation of what Chomsky, Hauser and Fitch were talking about. I am trying to kind of simplify and give you a paraphrased version of all of this, because again we are not really into a language course. We can talk about this if at some point I am giving a total course on language, but the idea is you have to just get the concept of what I am talking about. So, what I am talking about is that this system of syntax, this system of rules is what kind of specifies what is there, how things are to be executed in the sensory motor system, and it interacts with the conceptual intentional system via semantics. What has to be talked about, how it has to be talked about, and those kind of things. This faculty of language narrow, this system that is considered unique to humans, involves the ability of recursion. Okay. So, faculty of language narrow is that system that can take can take a finite set of symbols, phonemes for that matter, or and generate an infinite array of discrete expressions. So, you take just these 48 phonemes, use particular sets of rules, and you can create infinite language. So, what is it that is allowing us to do it? That is this system, faculty of language narrow. So, again this is what the biological system or the biological perspective of evolution of language or evolution of syntax or grammar is. The other interesting view, slightly in slightly contrary to what the biological view says, is the fact that language systems basically were not as complex as they are now since the beginning. These systems have become so complex and so sophisticated due to the process of transmitting through generations. The language that probably our ancestors were speaking was not this complex. It was not as rich as our language is, but what has happened is that it has been changed, it has been passed on from generation to generation through various processes, and that is what has led to this nature of language. One of the example of this process is called grammaticalization. I mean, you see that language is changing all the day. Sometimes people at some point people wanted to say I want to do this. Now you can hear people saying, and I want to do this, or I'm gonna go to this place, or I'm not it's not like I'm going to go to this place. This is too old fashioned probably. So, somebody would say I am going to go to this place, and there are, again these are very simple examples. There are so many other examples in which the language has changed, and language keeps evolving through societal interchange, through the number of people they are speaking. You can always see, say for example, there are almost all the time new words coming up, new words being added to the Oxford Dictionary of Words, new words being added not only in English for that matter, in Hindi as well, in other languages as well. And how is that happening? That is happening as a part of a social exchange. So, that is something which one needs to remember. So, the idea is that cultural transmission basically triggers and facilitates evolution of language. It is not biology per se, maybe biology has a part to play, but mostly the dominant or driving factor in evolution of language is the cultural factors, is the transmission across ages. Daniel Everett is one of the leading scientists in evolution of language. He is basically, he went to live in Brazilian Amazon, and he came across a tribe called the Piraha tribe, and he basically documented the kind of language they were using, and he basically documented one of the very interesting things and says that Piraha basically lacks what is called recursion. And he says that is a self-sufficient language, that is a language that this set of people are using. And so, the claim that Hauser and Chomsky and these people were making earlier, that every human language should have recursion, is contestable. Again, there are different ways and there are different manners in which this debate has been handled. There are different manners in which people have referred to Everett's views or Chomsky's views, but the idea is, again, there is some contrariness, there is some debate between what basically can be thought as the basic process of language or the basic driving force of evolution of language. There are other interesting things as well, but one of the things, again I'll just take a bit of a break and talk to you about, is if you really have to look at having a more rounded or inclusive approach, you can actually look at this very interesting paper by Christiansen and Kirby, and they basically talk about learning of language or evolution of language as a tripartite process. They say there are three aspects: there are individual learning, there is cultural transmission, and there is biological evolution. And the idea is that biological evolution, whatever you are born with, whatever you are inherited from your various species, you will also add to it your individual learning, your experiences about language, your ways of using language, the kind of words that you are using now, the kind of words that your children will be using, those kind of things. And you will kind of transmit this individual learning to your children, and they will transmit it to their children. That is basically these kind of learning biases, what kind of words you want to talk about. Nowadays you will see a lot of people talk in terms of WhatsApp language, SMS language, Twitter language, and the idea is they're kind of reducing and condensing language. Nowadays nobody really wants to talk in Victorian English, which used to have sentences like 3 lines or 4 lines or 10 lines long. Nowadays people like to talk in crisper, shorter sentences. So these kind of learning biases will in some sense govern what is the nature of the language that is going to be transferred to your later generations. So this will basically also be one of the factors that are driving linguistic evolution, and this linguistic evolution is basically what is considered as part of language. This linguistic structure changes what is called the fitness landscape. So suppose for example there are a set of words that people are using all the time, and that people are continue using over time, and some of the words, some of the structures just fall out and they are not being used at all. So the fitness landscape is because a lot of people are using particular kinds of words, particular kind of sentential structures. Those are the sentential structures in words that will survive. So that is the fitness landscape. And if those are the structures that only survive, they will have some bearing probably on the biological evolution as well. Again, I am talking of a much broader time scale. I am not really talking about this in 5 years, 10 years, 1 generation, 2 generation. I am talking about a much broader time scale here. So all of these three processes contribute almost in a cyclical sense, and the cycle could be of thousands and millions of years for that matter, which will drive what is called evolution of language. So again, this is something that I am kind of more at home with, because this approach kind of keeps into mind three very important aspects. It keeps in mind evolution, individual, and biology, all of the same time. That is one of the reasons why evolution of language is basically at this moment studied from so many different perspectives. There are neural correlates that you would want to talk about, there is articulatory physiology that you would want to talk about, you would want to talk about models of evolution of language. A lot of computer scientists, robotics, artificial intelligence people, machine translation people, natural language processing people are trying to build a particular kinds of models of language. How is language understood, how is language produced, what are the rules and patterns in here. Psycholinguistics, linguistics are more concerned about the structure of language. What happens if this word order is reversed, what happens if there is a relative clause and subordinate clause, what are those kind of things. Also a lot of people try to do comparative work between animal communication and human communication. There are people who are working with fossils to trace back the time from where human language would have started and date it in some sense, and kind of correlate it with other advances in human cognition. So it's such a varied topic, it's such a vast topic. You might be reminded of what this guy was saying in the beginning, that it's such a vast topic that it is actually very difficult to talk about language in any sensible way. There are a couple of other interesting theories that I'll just point you out to. You might if you want, go and read them. So one of the theories is the technological hypothesis of language evolution by Lana Ruck, and she says that adaptive selection of skilled stone tool makers was one of the primary drivers of the overall extension of large scale praxis. Now again, it sounds a bit complicated. I'll just sum it up for you. The idea is that when people started making intricate tools made of stone, if you have to really sharpen a piece of stone, you have to be very soft with it, you have to have very refined gestures on it, and that is something that kind of defines the kind of dexterity that was coming up. and this dexterity basically transferred from just manual gestures, dexterity of fingers, to vocal gestures, to these fine muscles developing and allowing us to speak the language that we are speaking. So she believed that technological hypothesis could be one of the major drivers of evolution of language. The other very interesting theory comes from the mirror neuron hypothesis. I've probably talked about this in one of the earlier lectures. Mirror neuron hypothesis basically was given by Michael Corbelis and Rizzolatti and Draghiero, and these people are talking about it. The mirror neuron hypothesis is that when first individuals started making vocal gestures, and there is this set of neurons in the frontal area of the brain, that if I'm making a particular gesture, you can look at me and you will try and make the same gesture. And the idea is this is probably what would have led to propagation of these kind of gestures, manual gestures and later vocal gestures, and that would have been the driving force behind evolution of language from being just a vocal gesture made by one person to 2 to 20 to 40 to 5,000 people, and could have actually contributed to evolution of language and spread of language across the human species. So that's probably all from me about language evolution. We talked in this lecture about some historical background of psycholinguistics and also evolution of language. I'll talk about some other topics related to language in the next lecture. Thank you.